Hello everyone, this is Deep and today we will be discussing LeetCode problem 2492, that is minimum score of a path between two cities. So here we are given a cities from 1 to n and a 2D array roads where there is a road between a city A to city B and the distance between the two cities is given in this distance integer. Further, the roads are bidirectional and the complete graph may not necessarily be connected. This means that there can be more than one connected components in a given graph. Further, we are asked to find the score of path between two cities. The score means the minimum distance of a road in a path. So that means, for an example, let's take a path of a city 1 to city 4. So if we take this path from 1 to 2 to 2 to 4, then the score is the minimum distance in the given path. So that is 5. If we take the path directly from 1 to 4, then its score would be 7. So that's the meaning of the score. That is the minimum distance of a road in a path. Okay. And finally, we have to return the minimum possible score of a path between city 1 and n. So for two cities, that is city 1 and the last city, city n, we need to return the minimum possible score. Okay. Further, we are given three important points. That is, a path is a sequence of road between two cities. It is a sequence of road. A path can contains more than one cities. Okay. The second point says we can visit same road multiple times or same city multiple times along the path. So we can, for example, if for a path from 1 to 4, if we go through 3, let's say from 1 to 2, 2 to 3, 3 to 2 and 2 to 4. So that is also one valid path. And the last point says that the test cases are generated such that there is at least one path between 1 and n. So there will be always a path between the city 1 and the city n. Okay. So let's take an example of this first test case here. So we are given node 1 to node 2, node 4 and node 3, and the distances are 7, 9, 5, 6. Okay, so one route would be directly from 1 to 4. Its score would be 7 because the minimum distance in this path is 7. The another would be from 1 to 2 to 4. Its distance would be 5. Another possible path is 1 to 2 to 3 to 2 to 4, and its distance would be also 5. Minimum distance along this path is 5. So there is no other possible path to travel from 1 to n. So we return 5 as our answer. Now in the same example, if we would have instead of 6 here, if we would have, let's say, 2, the distance between 2 and 3 is 2, then we would take this path and our answer would be 2. Okay. Yeah, so similar is the second test case. So now there was one point in this question that the graph may not necessarily be connected. That means if we have some graph like this, let's say 1 to 2 to 3 to 7 and 4, 5, 6. Okay, we have this graph. Let's say I number the distance 6, 7, 5, 3, 2. So in this case, we have to find the distance between 1 to 7, means we have to find the score between 1 to 7. So we won't look at this component because this component is not connected to 1. So we won't look at this, and we will only search for minimum distance in this graph only. So the answer would be 5. So one thing to clear is that we have to look for the graph or the connected component that is 1, and we just have to return the minimum distance from it. So 2 points to note. Check for connected component and return minimum distance road from that component. So these two things we have to note while solving this question. Further, one simple method is to group all these connected components together is by disjoint set union or DSU. So DSU will select any one node as a parent and will make all the nodes or all the other nodes parents as the same. For example, here if 1 is a parent, then 2's parent will be 1, 3's parent will be 1, 7's parent will be 1. And for all the nodes from 1 to n, we will check if the parent is same as the parent of 1. Like parent of 1 is 1, parent of 2 is 1, and similarly for parent of n is 1. So we will check if the parents is the same as the parent of 1, and we will choose the minimum distance from 4 of these nodes. Okay, so this is this DSU's data structure makes it simple. I hope this is clear now. Now let's move on to the coding part. So firstly, here I have used this code snippet of DSU data structure. So I will also paste this snippet into the description. Yeah, so moving ahead. So here we are given a 2D vector rows and total number of nodes n. So for starting, what we will first, we will create an object of DSU of size n plus 1. Further, we will create a graph in this DSU by adding the edges of these roads. So for auto r of roads, we will first take the node 1 equal to r of 0, node 2 equal to r of 1, and we will merge DSU dot make union, or merge, whatever you say, dot make union of node 1 and node 2. This means that we are creating a group of similar components, or the connected components here. Further, let's initialize an answer variable that we will return in the end. Then find the parent, and let me name it as x, and find parent of 1. Okay, now for all the nodes whose parent is same as the parent of 1, we will check for minimum distance. Okay, so let me first initialize answer as some big variable like int max. Now for all, now again we will traverse these rows to the vector. So here node 1 equals to r of 0, node 2 equals to r of 1, and distance equal to r of 2. Okay, now we will check for the parent. So if parent 1 equal to DSU dot find parent of node 1, and parent 2 equal to DSU dot find parent of node 2, and if the parent 1 or the parent 2 is equal to the parent of node 1, then we would check for minimum distance. So that answer would be the minimum of answer comma distance, and in the end we would simply return our answer variable. So first what we did is we grouped the connected components, then we find then if the node belongs to the same component as the 1, then we check for minimum distance. So these two things we did, and now let me try to run this. Okay, it's just pair 2. Minimum of answer and distance. Well, let me try to now submit this. Okay, so it got accepted. So let me just brief it out once. First, create a DSU data structure, then we may union all the nodes that are connected. Then if the node belongs to the same group as the node 1, that is if the parents are same, then we check for minimum distance. So I hope you guys understood this question. So that's all for this video. I hope you guys liked the video, and if you have any doubts, let me know in the comment section below. Make sure you like the video and subscribe to our channel. Thank you.